Hello! Welcome to another week of Techno Apps subject. I'm your teacher, Shalame W. Pareja. For this 8th week, let's talk about Piezo buzzer and car parking collision detector. This topic is under Techno Gadget. Sound or sounds has a huge impact on our everyday lives. Mostly, all the devices that we use can produce and interpret sounds. Being able to produce sounds using Arduino is a great way to enhance our microcontroller projects. So, sound is produced by transmitting vibration of the particles of the medium. At any time an object in an air vibrates, it causes compression waves in the air. So when we talk about sound waves, it can cause compressions in the it causes compressions waves in the air. So these waves are called sound waves, and it moves away from the objects at sounds. So the speed of vibration or hertz is the pitch of the sounds. The higher the frequency of the vibration is, the higher the pitch. So we also know that sound wave has the same characteristics as many other type of waveform. It has wavelength, amplitude, velocity, or speed, and frequency. So as we are talking about wavelength, wavelength is the length between two consecutive crests or two consecutive throw or a wave. Wavelength is represented by a Greek letter lambda, which is a shorter wavelength, has a louder sound, while a softer sound is a longer wavelength. The next part of sound waves is, aside from wavelength, is amplitude. Amplitude is the energy of the sound. It is the measure of the change over a single period. Louder sound has a greater amplitude, and softer sound has a softer amplitude. The next is velocity or speed. This is the distance covered by sound wave in a unit time. It is also called distance traveled per second. It can be the product of frequency and sound. So, here is the formula for velocity. Velocity is equal to distance divided by time taken. Velocity of sound wave is equal to frequency multiplied to wavelength. The next one is frequency. It is the number of waves that pass in a unit of time. So for example, if you produce 50 sound waves in seconds, the frequency is 20 Hz. So here is the formula for frequency. Frequency is equal to velocity divided by wavelength. So if we consider any wave in terms of velocity and wavelength, frequency is equal to c divided by wavelength. So if we consider the speed of light, so it will depend on what type of formula you will use depending if you're going to consider the terms of velocity and wavelength and consider the speed of light. So the question is, how do Arduino produces sounds? So you can generate or we can generate sound with Arduino in a number of ways. One way is to drive or attach a loudspeaker or piezo buzzer to it. So Arduino cannot actually make a wave, instead a square waves it produces. So these waves oscillates between a high and low values and switches instantaneously. So using potentiometer in line with a speaker or buzzer, we can control amplitude by changing the amount of current permitted to flow through the speaker or the piezo buzzer. So speaking of, a piezo buzzer is a tiny speaker that can be used to generate loud, annoying noises. You can directly connect a piezo buzzer to your Arduino board to play tone or detect tones. These buzzers operates in reverse principles of piezoelectric properties. It contains very thin plates that is made up of certain ceramics instead of quartz crystal. So when an electric field is applied to these plate ceramics, they push on one conductor and pull on the other. The result of the push and pull is a sound wave. Here is a picture or sample of piezo buzzer and also the standard schematic symbol for piezo buzzer that looks like a loudspeaker. So mounting piezo buzzer. So a piezo elements are not polarized. So you can mount or connect it in any direction. So to read the output of the piezo buzzer, you can just hook the positive pin to any PMW digital input of the Arduino board and connect it to the ground pin of the Arduino board. So a 220 ohms resistors is used to limit the current that flow through the speaker. So as you can see, here is a diagram or the wherein we can see that it is an example of a direct mounting of piezo buzzer to an Arduino board using also breadboard and 220 ohm resistor. So in connection to that, we have here car parking collision detectors. So let us learn how to create a backing collision detector with the aid of proximity sensor and piezo as the buzzer. So modern cars today are often equipped with parking collision sensor installed in the rear bumper. So as you can see here, the electronic sensor is installed in the near bumper. So the driver when parking in reverse will hear higher intensity beeping sound upon closing out with the obstacles. So the key here is that ultrasonic proximity sensor that determine the distance between objects. So with our activity, we will be making our own parking collision detector using the available ultrasonic proximity sensor in piezo to act as a buzzer using Tinkercad for our simulation. So the materials we need are the following. Of course, we need Arduino Uno, one Arduino Uno, one breadboard. The next is one piece of 220 ohms resistor, electronic proximity sensor, and piezo. So this is the design of our circuit, the car park collision detector breadboard view, and on the left side, and on the right side is the schematic diagram of our circuit, wherein you can see the view of our car parking collision detector. So to do so, connect the 5-volt supply and ground to the breadboard's power buses. So place the electronic proximity sensor on the breadboard and connect it to the VCC pin to the 5-volt supplies and GND to the ground. So connect the trig pin to pin 9 and echo to pin 8. So the principle on how this works is the sensor will emit a high frequency sound through trigger part, then the sound upon reaching an obstacle will bounce just like an echo. So the echoing sound will be received by the echo part of the sensor. So the time difference between the trigger and the echo determines the distance between the sensor and the obstacles. We have to take note that the sound travels at a constant speed in air. So the Arduino will be able to get a sound and process this crucial information through pin 8 and pin 9. So let's connect piezo source to pin 11 and its ground in series with 220 ohm resistor. So that will be the output of our circuit. So after having our connection, here are the codes needed. Of course, the program starts by sending a signal to the trig part to emit high frequency sound. The signal is sent in 2 and 10 intervals. Then this is done through digital write command. The echo part should be able to receive back the sound, and then the time difference between the emitter and receiver is obtained using pulsar in command and eventually stored in the duration variable. So the next part of our program is this. So the distance is computed on an equation that is also dependent on the duration variable. In reality, the sensor's range is 350 cm, but for this purpose, the range was reduced to 100 cm. We formulate several if-else statements to check the actual distance and a sound value for the piezo. The piezo should be able to produce high-intensity beeping sound once the distance becomes smaller. So if you look again at our if statements on our code, we will notice that the sound value increases with the decrease of the distance. Finally, command our piezo to vibrate and produce a sound with the tone command using determine sound value. So if you have any more questions or clarifications to this, we will proceed on answering our objective test and performance test. And also, if you have any more questions, clarifications, or suggestions to improve our lessons about Techno Gadget, please do not hesitate to send me an email, an SMS, on Facebook, MS Teams, also on my available email address and contact number. Always remember to stay safe and happy learning to everyone. Thank you very much.